Welcome back, students. This video we're going to cover Module 11, Topic 3. This is area of circles and sectors. This is page 9 of the Module 11 Module 11 packet. Standards for this particular lesson. GR 4.4. Solve mathematical real-world problems involving the area of two-dimensional figures, and then GR 6.4. It's involving arc length and area of a sector in a given circle. The objective of this lesson, you guys are going to be able to find the area of circles and sectors. All right, so the warm-up. Circle graph to the right shows the percentage of students who voted for each ice cream flavor. Number 1, if the radius of the circle graph is 2 centimeters, what is the circumference? Okay, well, so we know circumference is 2 pi r. So that's going to be 2 times pi, and the radius is 2. So 2 times pi times 2 gives us a circumference of 12.7 centimeters. And this is length, linear, like, circumference is the perimeter of the circle. So, all right, number 2, find the measure of arc ED to the nearest tenth of a degree. I think I had read that wrong in class the other day, but all right, so ED here is chocolate, and chocolate is 33%. So to find the measure of arc ED, it's going to be, in this case, we're just going to multiply 360 times 0.33, which is 33%. And when you multiply those out, it's 118.8 degrees. All right, number 3, find the length of arc ED to the nearest tenth of a centimeter. All right, so here, because we're looking, again, linear, so we're looking for the length of this arc. So we're going to take the circumference of this. So the whole way around is 12.7 centimeters, 12.57 centimeters. So we're going to multiply that by the percentage, the 33%, which is this much of the circle. So ED is going to equal 0.33 times 12.57. Then you multiply those together. So the whole circle was a little over 12.5 centimeters. This 33% of it is 4.1 centimeters. All right, so moving down. So we're going to recall from in Module 10. So the formula for arc length can be given by the equation below. And how can we break up this equation? So L stands for arc length, and it equals theta. That's the measure of the angle divided by 360. And I call that the percent of the circle. It's going to be used for sector as well as arc length. It's just here, this is circumference, 2 times pi times r. And when we get to sectors, it'll be pi r squared because it's area, not linear like the circumference here. But this part's the same, and that's the percent of the circle. I don't know if that's the right term, but that's the term I use. All right, so number 1. We got practice problems. 1 and 3 are going to be our I do's. 2 and 4 are going to be for you guys to do on your own. All right, so number 1, find the length of the minor arc. So recall, minor arc is less than 180. A semicircle is 180, and then a major arc is over 180, or more than 180. So minor arc, 45. So they say that so we'll know what to look for. So theta in this case is 45 degrees. That's the measure of that angle. And we're multiplying that by 2 times pi times the radius. The radius in this case is 3. All right, so we multiply this out. Let me put the formula over here. Well, it's up there. You can see it. So theta in this case is 45. All right, so we multiply all this out, and the L is going to be 2.38 centimeters. And it's not squared because it's linear. It's the length. All right, so number 2, you're going to use the same formula up here. There's your theta. There's your radius. All right, let me So I'm telling you that because I'm scooching this down here just so we can get these bottom two problems in the frame. All right, number 3, the length of an arc is 3. The radius is 2. What is the measure of the central angle? So we're just deconstructing the formula up there, and I'll write it here. So arc length equals theta, or the central angle, divided by 360 times the circumference, 2 times pi times r. All right, so we have the arc length. I'm going to do this in pencil so we can. So our arc length was 3. We're looking for theta. So theta over 360. We have 2 times pi, and then we have the radius is 2. Okay, well 2 times pi times 2 goes all the way back up to the top of the page where our bell ringer, and the circumference is 12.57. So we'll just put this in parentheses over here. We got 3 over here. And then we got theta over 360. I'm going to run out of room. So I'm going to go ahead and scooch down. So divide both sides by 12.57. These cancel. I'm going to move up here. And it's going to be theta over 360 on the one side, because those canceled, equals 3 divided by 12.57. Yeah, 3 divided by 12.57 gives us 0.2387. All right, now we're going to multiply both sides by 360. So these cancel. And we're left with theta equals 360 times 0.2387. And multiply those out, we get 85.9 degrees. And it said the nearest tenth of a degree. Okay. All right, number 4 is going to be the same way. They gave you the arc length. They give you the radius. They want the central angle. You're going to deconstruct it the same way I did here. All right, let's flip over. Page 10. Whoops, that's not page 10. That was last video, page 6. So here, page 10 now. Scooch, scooch, scooch. All right. So we're calling that the area of the circle is pi r squared. So now we're going to get into a little area of the circle, and then we'll talk about the sector. All right, so we got a couple of we-dos. Number 5, patio. Kean is building a circular patio in his backyard. Part A, what is the area of the patio to the nearest square foot? Okay, so this is the patio. The diameter is 24. Recall that the radius is half of that. So the first thing we're going to do is find the area, which is pi r squared. Our radius is 12. So it's pi times 12 squared, which is 144 pi, which we multiply that out, and we get 452.4 feet squared. Square feet. Okay. So now we got part A. Now part B, he wants to purchase paving stones at 135 per square yard. Notice yard. We had feet, so we got to do some converting. So how much is he going to spend? Well, first, all right, so we have, now see where I had this 144 pi? I was thinking ahead. So I'm going to say 144 pi. That's the area, or, that's our, how much area we have in this whole patio. And 1 yard, or 1 square yard is the same as 3 square feet squared. Okay, so we end up multiplying or dividing 144 by 3, and it's going to give us 16 pi in yards. So it was 144 pi feet squared. Now we have 16 pi yards squared. So we've converted from feet to yards, and now we just need to say, so 16 pi times, it's 135 per square yard. So 135 for 1 yard. And then you're just multiplying. Basically, we're multiplying 16 times 135. Hang on one second. Something's not right. Give me just a second. Times 135 times pi. Right, times pi. That's where my own notes confused me. So, yeah. So, excuse me. So 16 times pi times 135, because it's 135 per square yard, and he's going to have to spend $6,786 for pavers for his patio there. Okay. Number 6, Mr. Jimenez wants to create a corn maze in his field for a local festival. At the center of the maze, there's a circle with a diameter of 150 meters. What is the area of the corn maze? So it's kind of worded strange, but essentially the diameter, 150 meter diameter, is for the whole corn maze. It's not just for the circle in the middle. All right, so if our diameter is 150, our radius is half of that, which is 75. So what do we got to do first? We have to have area equals pi r squared. So our radius is 75. So 75 squared times pi gives us an area of 17,671 square meters for Mr. Jimenez's corn maze there. All right, let's flip down the page here. Number 7. Find the diameter of a circle with the area of 196 pi square yards. So the way you do this, so we have, let's put our formula. Area equals pi r squared. They told us our area is 196 pi. This side stays the same. We just plugged in area for area. Okay. So divide both sides by pi. These cancel, these cancel. So now all you have is r squared equals 196. So 196, we got to take the square root because we need the radius. Well, they want the diameter. We're going to find the radius, and then we're going to double it to make the diameter. So if you take the square root of 196, that's 14. So the radius is 14, and the diameter is twice that. I'm not even going to write 2 times because you guys need to know the diameter is twice the radius. The radius is half the diameter. All right, number 8. You guys work that one. That's the you do. Going to work the same way. Put the formula. Plug in where they tell you the area, and then cancel out till you get radius on one side, radius squared on one side, and the number. Take the square root, and you know that. See, you want the diameter. So what do you do next? All right, notes under still page 10. So a sector is a region of a circle bounded by the central angle and its intercepted arc. The formula for the area of a sector is similar to the formula for arc length, what I mentioned before. So it's the percent of the circle, whatever the central angle is, divided by 360 times and this is just the area of a circle formula, pi r squared. So the area of the sector is the percent of the circle times the whole circle, the whole area of the circle. Okay, scooching down the page here. Number 9 is the I do. Number 10 is the you do. So let me do number 9. Sorry, in circle K, the measure of angle JKL, so this angle is 112. JK, so this side, that's a radius. See, it goes from here to the middle. It's 13. Find the area of sector JKL. So let's just do this. So, and they want area. So we're filling it in. That's why we need the whole area of the circle. And we subtract out the little Pac-Man there. All right, so formula. Area is theta over 360 times pi r squared. So here, theta is 112. That's the angle over 360. And pi r squared, pi, our radius is 13. So 13 squared. 13 squared is 169. So we multiply that by our 112 over 360. And we're going to get, this is nearest hundredth. So it's going to be 165.18 square units, or unit squared. Why? Because it's area, it's the amount of space in there. Number 10 gives you, they give you the angle, they give you the radius. You're just going to do what I did for number 9. Flip over page 11. This is going to be the last page for this topic. We've got number 10, 11 I'm going to do. Number 12, you guys are going to do that. I'm going to give you a little hint. And then at the bottom, I'm going to do 13, and 14 is going to be for you guys. So number 11. Malaya is playing a game where she must track the progress using sectors of a circle and a circular game piece. The game piece has a diameter of 3.5 centimeters and is divided into 6 congruent sectors. What is the area of one sector to the nearest 100th? So, diameter, and it's divided into 6 congruent sectors, okay? So what that's telling us is the angle, there's 6 angles. 360 divided by 6 is 60. If you divide 1 divided by 6, that's the same as 60 divided by 360. It's just, so our theta over 360, we can already just call it 1 over 6, because it's going to be one of these. How much is one sector out of 6? So when we do our this, it's going to be 1 over 6 instead of something over 360 times pi. And remember, this is the diameter is 3.5. Radius is half of that, which is 1.75. Just make a habit of, all right, do I have a diameter or do I have a radius? And which do I have and which do I need? And get that right. So this is going to be pi times 1.75 squared. So we do all this math, taking the area of that circle, and then we divide it by 1/6, or multiply it by 1/6, or divide it by 6, because it's the same thing. And I put length, I'm sorry, it's area. I don't know why I put the L, I guess because we were talking sectors. But we do the math, and it's 1.6 square centimeters. That's how much one of these is. The whole thing is that times 6, which was right here. All right, number 12. So this is what you guys are going to do. You're going to do the same thing I did here, except notice, so this guy's graphing a clock. Your hint here, so a clock, how many sections does it have, or how many hands or numbers? It has 12. So this is going to be 1 over 12. I'll just write this in for you. So make that a little more visible. 1/12, because it's a clock. So there's your hint. All right, number 13. So I'm going to do 13. You guys are going to do 14. It's going to work the same way. Numbers are a little different. It's going to solve the same way, though. All right, so one sector of a circle has an area of 42 square feet, an arc measure of 45. So there's your theta. Find the area of the circle to the nearest foot. First, we got to find the radius. So they gave us the area. So for the arc, they gave us the area. They gave us theta. But we got to find the radius. So this is the formula. Now let's plug in what we know. We know 42 is the area. We know 45 is the theta. And we're trying to find R, or the radius. So, how did I do this? All right, so the first thing we're going to do, divide both sides by pi. That cancels there. 42 divided by pi is 13.37. So we still have 45 over 360 here. And we still have radius squared because pi is gone. All right, so now, 45 over 360 is the same as 0.125. Okay, so I just replaced this with this. Now, I'm going to divide both sides by the decimal, 0.125. That leaves r squared by itself because these two cancel. And 13.37 divided by 0.125 gives us 106.96. Okay, whoa, Lord, hold on. Let me wait for this to come back. There we go. So yeah, 13.37 divided by 0.125 gives you this. Now that's the radius squared. We want the radius, so we take the square root of both of these. And the square root of 106.96 is 10.34. Okay. All right, so now there is our radius. Now we want the whole area of the circle. Well, the whole area is just pi r squared. So that's why we needed the radius. Pi times 10.34 squared. Multiply all that out, and you'll see that the whole area of the circle was 336 square feet. Now, let's see. I want to try something real quick. Could we have... Let me see. I just want to try something real quick. Well, I'll try it later and let you guys know. All right, so number 14, you're just going to do the same thing as I did here. We're just plugging in our numbers there. You're going to get the radius first, and then you're going to get the area of the circle. If you have any questions, let me know in class. Until next time, have a good night.